Okay, so I wanted to do this as a warm-up together to review average and instantaneous rate of change. So find the average rate of change between x equals 4 and x equals 5. So because I'm going to use the same function all the way through, I'm just going to take the time to plug it into my y equals menu. So I've got 3 parentheses x minus 2 squared minus 2. And so once you have it in your y equals menu, you hit second table setup. I'm just going to start at 0 and count by 1. Then second table, so I can grab now, I want 4, so I have 4 comma 10 and 5 comma 25. So 4 comma 10 and 5 comma 25 are my two coordinates. So if this is just average rate of change, that's just y2 minus y1 over x2 minus x1. So 25 minus 10 over 5 minus 4. So that's just going to be a total of 15 or 15 over 1. So you can pause the video and try example 2 to find the average rate of change between 0 and 1, and then watch the video of what that answer is. So now I'm going to say what the answer is. So my 2 points are 0 comma 10 and 1 comma 1. So I'm doing 1 minus 10 over 1 minus 0. So that looks like negative 9 over 1. So just negative 9. So you might have a negative average rate of change. If I look at the graph of this, see how between 0 and 1 the slope would be negative between those 2 points? So it's okay to have a negative rate of change. So now let's do instantaneous rate of change at 3. So remember, instantaneous rate of change, if we don't have 2 points, like x being 0 and x being 1, we have to make up our own points. So we're going to use the points 2.99 for x and 3.01 for x, and we're going to figure out our y values. So in your table, you're going to go to table setup, start at 3, and count by 0.01. Second table. So 2.99, my point is 0.9403, and at 3.01 in my table, 1.0603. So to find instantaneous rate of change, now you do take the y2 minus the y1 over x2 minus x1. That's just going to be 0.02. I like to put my numerator in parentheses. 1.0603 minus 0.9403 divided by 0.02. So I got an instantaneous rate of change of 6. So looking on the graph at 3, the steepness right there has a steepness of 6. So if this was birth rate or the speed of an object, instantaneous rate of change gives you the velocity, how fast something's going. Now it wants me to find the instantaneous rate of change at 2. So to find it at 2, I'm going to kind of split that difference around 2. I'm going to go to 1.99 and 2.01 in my table setup, start at 2 this time. So at 1.99, it's negative 2, and 2.01, it's also negative 2. So when I do y2 minus y1, I actually get 0. So 0 divided by 0.02 is still 0. And it says, why do you think this is so? What's happening on my graph at 2? Oh, it's where the vertex is. So when the graph changes direction, it actually has an instantaneous rate of change of 0. So for a split second, it stops and changes direction because it's the vertex. So it's changing direction. So that review hopefully will help you remember how to find average and instantaneous rate of